Welcome to the Sun This Week for the week of the 16th to the 23rd of February 2005. I've subtitled this particular presentation The Many Faces of the Sun. And as you can see, there are different sets of images here taken at different temperatures, peeling away the different layers of the sun. On the left we have the low temperatures at about 6,000 degrees Kelvin. On the right we have a picture taken at 10 million degrees Kelvin. And we can learn different things from the sun from each one of these layers. Based on the last 24 hours, I would say that solar activity is high at the moment. The sunspot number has risen to 180. Over the week, the flare activity has been quite high as well. We've had 77 C flares, 7 M flares, and 1 X flare just a few hours ago. In fact, we've just had another M flare while I'm recording this. We've had several minor geomagnetic storms to go along with all this activity. The prime suspect in all this activity is generally sunspots. And so let's take a look at the sunspots. You can see the sun as it is currently pictured here on the right. However, if you look at the sunspot numbers, that's the plot on the left from the Solar Influences Data Center in Belgium, you can see that the current sunspot number is about 180. This week it's been as low as 115. However, if you go back exactly one rotation, so the same face of the sun would be facing us as it was one rotation ago, then you'll see that the low point was 55. So the sun has filled in the sunspots in this area by over 100 points. So let's take a look at the continuum movie of the sun for the last 7 days and see the comings and goings of various sunspots. Particularly look for emerging regions and decaying regions. Moving higher into the solar atmosphere, we're going to go to the transition region, and we're looking at helium-2 304 angstroms here. This is about 50,000 degrees. You can see filaments, those are the dark areas on the surface of the sun. Prominences are the bright areas above the limb of the sun. And both of those are the same thing actually, and can erupt and cause coronal mass ejections. And sometimes when they do, they also create two-ribbon flares. Now we move up to about 750,000 degrees. This is the lower or the quiet corona. It's a network of magnetic loops connecting sunspot regions. Some of them are very large scale, as you can see here, going hundreds of thousands of kilometers up into the solar atmosphere. There are also some transequatorial loops which connect regions in the northern and southern hemisphere and indicate reconnection between those two regions, which is part of the decay and growth of solar cycles. One of the themes we've been concentrating on in our daily reports is the fact that there's a lot of coronal holes about at the moment, and today is no exception. You can see there's some large coronal holes here, and these have actually grown since the last rotation. So let's take a look at the development of the coronal holes in the form of a movie using the 211 angstrom channel from the AIA instrument. This is at just over 1 million degrees. Now we move higher into the atmosphere yet again and to higher temperatures. This is over 2.5 million degrees. These bright areas here are active regions. They are the coronal equivalent of sunspot regions. In fact, sunspots are under these regions. They are magnetic loops that are trapping hot plasma, and so they glow. You can see minor flares in these regions, and new regions coming over the limb several days in advance. And in fact, if you look on the east limb here, the left limb, you can see 2 new regions have just come over that limb, and there are sunspots associated with them that you may have noticed in the earlier movies. Now we go to our flare channel. That's the highest temperature channel. That's the 131 angstrom channel from the AIA instrument. That's 10 million degrees. All the bright flashes in this movie indicate big flares. The brighter and longer a flare lasts, the more energy was emitted. As a special bonus, here's a quick movie of the X-flare that we just had. Now we move much higher in the solar atmosphere, but not to higher temperatures. This is the quiet corona expanding out beyond the surface of the sun. In fact, it suffuses the whole of the solar system out well past the Earth. This is lower resolution, so we can see the speed of CMEs, we can see their acceleration, we see their location and their dimensions. Once again, thank you for listening. If you enjoy these videos, please pass them on to friends or neighbors or relations who you think might benefit from understanding more about how the sun works. And so until next time, stay safe and goodbye.